Hello student, this is Shiv Shankar Tale from Mechanical Department, Government College of Engineering, Bikaner. In last lecture we have discussed about the multi-evaporator. Now in this lecture we will discuss about the multi-evaporator with multiple expansion valve system. We have discussed in the last lecture by using the multi-evaporator, okay, that much amount of no effect on the COP or the performance of the refrigeration system. मतलब एक से ज़्यादा evaporator यूज करने से कोई परफॉर्मेंस में इंक्रीज नहीं होने वाला रेफ्रिजरेशन सिस्टम या COP में कुछ इम्प्रूवमेंट नहीं होने वाला है. देन आप क्यों यूज कर रहे हैं कि देन मोर देन वन evaporator क्यों यूज कर रहे हैं? बिकॉज for working of the refrigeration system at two different temperatures or more than the one temperature. Okay, if you use the two evaporator, it means refrigeration works at two different temperatures. If you use the three, it works at three different temperatures. Okay, that is only the purpose of this by using the multi evaporator. Okay, now we'll discuss about the working and the how to calculate COP of this multi-evaporator with multiple expansion valve system. The difference between the individual expansion valve system and multiple expansion valve system, only this much is the difference, the position of the expansion valve. Okay, because in both if you see this diagrams, these two diagrams, here also a single compressor, here also a single compressor, here also single condenser, here also single condenser. Evaporator, two evaporator, one is evaporator works at higher temperature or higher pressure, other temperature is at lower temperature or lower pressure. Okay, only the position of this expansion valve system. Now how it works, that is saturated liquid that is outside of the condenser comes in the first expansion valve and expanded that saturated liquid, and that expanded liquid or refrigerant goes into this, some amount of that goes into the evaporator 1, that is the higher temperature evaporator, and the remaining, because at point 2 there is a mixture of the liquid and the vapor. Okay, at whatever amount of liquid comes into the second expansion valve by using the flue gas system. Okay, only the remaining amount of saturated liquid. That's why the second expansion valve process takes place from, see this pH diagram, from the process 4 to 5, and then goes into the lower temperature evaporator, that is E2, that is the process 5 to 6. Okay, now we'll discuss or how to calculate or what is the difference between individual expansion valve or the multiple expansion valve system. If you see this individual expansion valve system, the evaporator 1 or the higher temperature evaporator takes place 2 to 4 and the lower temperature is 3 to 5. Okay, here in this case the more amount of refrigerant effect gives the higher temperature evaporators, that is the E1. Okay, from the, if you see from the pH diagram, but if you see in this multiple expansion system, the more refrigerant effect gives the lower temperature, that is the E2 here, that is H5, H6 minus H5 is greater than H3 minus H2, means the higher refrigerant effect gives by the lower temperature evaporator. But in individual expansion valve system, that is H4 minus H2 is greater than H5 minus H3. Okay, in this system, in the individual expansion valve system, the higher temperature evaporator works effectively compared to the lower temperature. But in the second multiple expansion valve system, the lower temperature evaporator works effectively than the higher temperature evaporator. Okay, in the both the case, the compression is takes place from in the compressor entry point is at the superheated region in both the cases. Okay, means here the if you combine the total refrigerating effect, that is refrigerating effect of the evaporator 1 E1 plus E2, that means QE increases. Here the compression starts from the superheated zone, means the work required for the compressor also increases. Okay, if both the increases, means we cannot say exactly about the COP. What is the effect on the COP? Okay, it may increase or it may not be increased. Okay, depend upon the application. That much only the difference between the individual expansion valve system and the multiple expansion valve system. Now, how to calculate COP in the multiple expansion valve system? We know that COP equal to refrigerating effect, that is RE upon the WC. RE upon the WC. Now we know that RE, total RE, that is M1, that is mass flow rate, into the evaporator 1, that is H3 minus H2. This is the refrigerating effect of this evaporator 1, plus M2, that is amount of mass flow rate in the refrigerator 2, that is H6 minus H5, divided by M1 plus M2 into, that is the refrigerating compressor work, that is H7 minus H6. Okay, in this way you can calculate the COP of this system. Okay, but in the second multiple expansion valve, we can say that the effect of this multiple expansion valve, we can say that the lower temperature evaporator works effectively compared to the higher temperature, or the lower pressure evaporator works effectively compared to the higher pressure. Okay, we cannot exactly say about the improvement in the performance of the refrigeration system. Okay, that is the discussion about the multi evaporator. In the next lecture we will discuss about some numerical on this multi evaporator with individual expansion valve system, or the multi evaporator with multiple expansion valve system. That we will discuss in the next lecture. Okay, thank you students.